Hi, and welcome to Azure Conf. My name is Ido Flato, and in this session, we'll talk about caching solutions in Microsoft Azure. So a bit about myself before we get started. As I said, my name is Ido. I come from Israel, from a company called Seller Group. I do a lot of Azure development and consulting, but I also do a lot of server consulting, web, and stuff like DevOps, automation, and that sort of stuff. I also authored a couple of books and a couple of courses for Microsoft, among them WCF4 course a couple years ago, and also the Developing Web Services for Microsoft Azure also a year or two ago. So in this session, we're going to talk about different caching solutions. So the first thing I want to make clear is why we actually need caching, not necessarily in Azure, but generally, why do we use cache? So first of all, when we use web applications, for example, we have state, whether it's a session state or whether it's state that we save inside our application cache. And when we have a restart of our application, for example, we change something in a web config, our application pool gets recycled. In those situations, if we save something in memory, it will eventually be deleted and we'll have to load all that state again. When we use cache, external cache to our application, these types of states are getting persisted in memory. So we don't need to reload everything again, unless, of course, the cache shuts down for some reason. The other reason why we need caching is, for example, when we scale out our application to multiple servers. When we scale out our web applications, we tend to have the problem of the session key being different in our different servers. So the first thing we want to make sure is, of course, use the same machine key in all of our web applications. But in addition, what we want to do is to be able to share our session state between those servers. So when a user loads the web application and then browses different pages and the load balancer sends the request to more than one server, all the servers share the same state object and they fetch it from the cache. Okay? So that's another way of using distributed cache solutions. Now, these are options to make our state available in all of our servers, but there are many other reasons to use cache solutions. So first of all, let's look at a database. When we have a lot of users, thousands or tens of thousands of users, those users create a load on the database, whether it's for insert or select. And when we have a cache, we can actually store some of the information from the database inside our cache. So instead of hitting the database again and again on every request, especially for select statements, we can actually fetch that information from the database once, put it in the cache, and then pull it from the cache again and again without needing to go all the way to the database, thus reducing the stress on the database and also speeding up our data access, because when you use cache, you usually use in-memory storage. So the entire data that I'm caching is stored in memory, not in the database on hard disks and that sort of stuff. So we have a lot more throughput from caching solution than we can sometimes find in a database. So when we look for caching solutions, and there are thousands of caching solutions that we can use, well, maybe not thousands, but at least a couple of dozen. When we look for a caching solution, we usually have a checklist to decide if a specific caching solution fits our needs. So first of all, of course, every cache needs to have some sort of a key value operation. Get an item according to a key, add an item using a specific key, remove an item, or even locate an item according to its key or according to tags of some sort. We also, since this is a cache and it has a limited size of memory, we'll probably want some sort of an eviction policy. Say least recently used or least frequently used evictions to remove items from the cache to make more memory available for new items, or even expire specific items once we don't need them. For example, if this is some sort of a news ticker, we might want to have news that are 5 hours old and everything else be removed after those 5 hours. So we can have absolute or sliding expiration using daytime or time span for cached items. We would also, of course, like our cache to have concurrent access because, well, it must have concurrent access. We have multiple users. We won't want all the users to be sequenced into the cache when they fetch items. And of course, once we have a cache server, we'll probably want to have multiple applications using that cache server in order to use its entire set of memory. So we'll probably want to separate those applications and have different caches inside that server, also known as a multi-tenant cache host. And most cache solutions do have these features, luckily for us. Of course, if we are deploying our cache in Azure or on-prem, but we have external access to our network, we probably want to secure our connection, whether it's using some sort of a secure transport, such as TLS or HTTPS, if it's an HTTP-based cache. And of course, perhaps add an authentication mechanism that requires the computer that is using the cache, that is accessing the cache, to have some sort of a password in order to access the cache. Okay? And of course, one of the important things in caching is handling possible loss of data by supplying replication and clustering of our cache services. So when we talk about cache services during this presentation, I will of course mention which of these features our caching solutions have. Now, that being said, there are a couple of things that would be nice to have in a cache that really depends on the requirement of your application. Okay, you might not need them, but they might be a must requirement from your cache solution. So for example, bulk operations, if you want to insert thousands of items into the cache in one hit. Enumeration, if you want to iterate your items or even query them. There are even caching solutions that allows you to index your content like a document database, but in memory. So you can query them using some sort of a SQL statement or something that is similar to a SQL statement. Replication. We don't need to have replication. If our cache loses items due to loss of memory, we can just fetch them from the database usually. But if we do want our items to not get lost, we might want to replicate them between our different servers. So first of all, there is a difference between replication and clustering. Clustering means that we can have multiple machines for our cache, so we can have more memory. Replication means that, well, we'll have less memory, but our items will be replicated between those servers, so we'll have multiple copies in case something bad happens to one of the cache servers. Also, one other thing that is very cool in cache services is a notification mechanism. So for example, I want to know when one of our application server changes an item in the cache. I want to get a notification on that. Some of the caching solutions provide that option, so we can actually know and handle when something gets removed from the cache due to, say, a cleanup, or someone updates an item in the cache to release a lock we have on it, or stuff like that. Of course, some of our caches also support transactions. Some of our caches also support persistency of the data. So I can also save, if the caching solution, of course, supports that, save my in-memory items to the hard drive or to somewhere else in order to, for example, load them again after the machine crashes. So I can have an online backup, or I can have a frequent backup of my cache into the hard drive or to a database of some sort, just to persist my cache, so I won't need to worry about my machines going down and when they start up again to load everything from the database. Now, one of the things that it says here nice to have, but usually this is a must-have tool, some way to manage our cache, to flush all the items, to get a list of all the items that are in the cache, or at least get the size of memory that we are using from the cache, get the number of connections of clients, okay, and of course maybe even managing our cache, pulling items, updating items using command line tools, which is also nice to have. And these are mainly stuff that we see in a lot of caching solutions. So when we talk about caching in Azure, we're actually talking about a couple of variations that we can use. First of all, you can bring your own solution. If you're using Memcache, or if you're using Ncache, or if you're using any other caching solution, you can just create a virtual machine, deploy your solution to that virtual machine, define the endpoints, open the ports, define the firewall rules, and just have a virtual machine running a cache service just like you would have had on-prem. That's one of the options. By the way, you don't have to use a virtual machine. If your cache service can survive a machine restart, then you can also put it on a cloud service and have it maybe even scale out as you go along. And if you need more memory, just scale out the number of cloud service worker roles, and you will get more machines, more memory, larger cache service. Another option is to use a built-in service. There are actually caching solutions in Azure that are provided as a service that you can just create in 1 or 2 clicks, wait for a couple of minutes, and get a caching solution that you can use. We'll talk about that later on, of course, in this session. And there's also the option of third-party tools that provide you caching solutions in Azure as a service. So whether you buy them from the store, the Azure store, or whether you go to a website that hosts its cache services in Azure, such as, for example, Redis Labs, which provide Redis solutions and Memcache solutions in Azure and in other clouds. You can do that also if you don't want to create a VM, or if the type of solutions that you're looking for are not provided as a service in Azure. So when we talk about bring your own caching solution, what we mean is that you create a VM. It can be one VM, it can be multiple VMs if your caching solution supports replication and clustering. And you can just hook up your machines in Azure to connect to those VMs. So whether you're using the internal VNet or you're using public IPs, you can communicate with those VMs from websites, from cloud services, from from virtual machines. You can even connect your on-premises environment to your cloud environment. So for example, by using the VM's public IP, or even by using a VPN connection, you can have your on-prem servers connect to your caching VMs, and then you can use those VMs in your applications. So once you create a virtual machine, you bring your own solution, you can practically connect from to it from any type of application that you have in any hosting support in Azure. So let's go ahead and see this option by using a caching solution called Couchbase. So first of all, Couchbase is not just a caching solution. Couchbase is actually a document database that also has a caching option. So what I did is I went to the management portal, and I created a VM. This VM has a single core, and I just RDP the VM and install Couchbase in that VM. I can, of course, create multiple VMs, install Couchbase, and create a server cluster where all the servers communicate with each other and replicate the data. And once I have that VM, I installed Couchbase. You can see the admin here inside the console. I can open a command line and show you that this machine has an internal IP, 172.16.04. And I will actually configure my application to use this machine as its Couchbase server using this IP. So first of all, a bit about the arrangement that I have here. I have a web application deployed to an Azure website, and that Azure website is configured to use the same VNet, the same virtual network as my virtual machine. This is a new feature in Azure where you can have a website sitting in the same virtual network as your virtual machines or other cloud services. So I am able to use the internal IP. I don't need to use the external IP. That is why, for example, I can lower down my security boundaries a bit and, for example, not use a secured connection. Okay, maybe a password, but not necessarily a secured connection using TLS or HTTPS. So what I have here is a web application for a to-do list. It looks a bit like so. Okay, I have a web application, I have the to-do list here, and I can go ahead and enter the application. As you can see, I have already a to-do item for today presented at Azure Conf. I can create a new one, catch a flight back home, set it for another day. Okay, and then, of course, these are today's tasks. Let me just change the date to tomorrow. And you'll see that I need to catch a flight back home. Now, each time I access this page, the process is as follows. First of all, we look for the list of to-do items for the specific date in the cache. If it's there, we'll just pull it from the cache and display it. If it's not in the cache, we'll go to the database, pull the information from the database, store it in the cache, and then show it to the user. The process basically looks like so. Get the key that represents that item, try to retrieve it from the cache. If it's not in the cache, get it from the database and put it in the cache, and of course return it so we can render it to the user. So first thing, I browsed to the web application and I listed today's and tomorrow's to-do items, so they were already loaded from the database and placed in the cache. So if I go to my virtual machine and I refresh this page, this is the list of all the documents I have in the cache. You can see I have these two items here, presented Azure Conf and catch a flight back home. And these are the two items that I have in the cache, meaning the next time I go to my application, not correct one, the next time I go to my application and press enter, it will load faster because it loads from the cache and not from my storage. By the way, in here I'm using table storage, which is also faster than a database for this type of items. But it will be actually faster to retrieve it from the cache once I have a high load of users or once I reshape the items, because in here I'm actually storing lists of items inside the cache instead of pulling one item after the other or filtering according to date. I'm actually filtering according to a key here, which is the date. This is how I store items in the cache. And in this way, I'm able to load a lot of items in one operation instead of going to table storage and querying according to something that is not the partition key and not the row key. Okay. So if you want to know how I exactly working with Couchbase, so first of all, of course, after installing the Couchbase server, I opened my web application and I installed the Couchbase client. The client library, as you can see here in the NuGet packages. Give it a second to load. Okay, so I have here the solution for Couchbase. This is a Couchbase net client. I defined an interface for all my caching activities, which is get key, get items, replace item, add item, because basically what I'm doing, I'm storing, for each key, I'm storing a list of to-do items for that day. And when I add a new item for a specific date, I try to locate that list in the cache and add the item to that list. So the next time I query that date, I will automatically get all of my to-do items, including the ones that I just added, in one query of the cache. So to use Couchbase, I'm just creating a new Couchbase client according to the configuration. And my configuration, as you can see here, let me just scroll up a bit. This is the address of my Couchbase server, and this is the internal IP address of my Couchbase server. Okay, if you want to use a public IP, that's also okay, but just make sure that you're using a secured connection, especially with the password, so no one else can access that connection. So this is one option of basically using a web application with a caching solution deployed to a virtual machine. Just deploy it like you deploy it to your on-prem environment and use it using your client APIs. Basically just using a virtual machine. The other option I want to show is how to use stuff from the Azure Store. So in the Azure Store, we have a new caching option, which is called Memcachere. Let me show it to you. To access the Azure Store, we'll use the current management portal. So we scroll down to the add-ons. And you can see I have a solution here called Memcachere. I have it both in Europe and in the US. So let me open the US one. Okay, if you want to create this new option, just go to New, Store. Scroll down to M for Memcachere, and just create a new one in the region where your servers are. Select the one that the plan that you want to have according to the size of the cache and the support that you need, failover cluster, and that sort of things. I'm using the simplest one. And once I got this cache created, I can, of course, go to the dashboard and see how many items I have in that cache, how many connections I have open to that cache. So currently, I have 0 items. So what I can do, now that I have the information of that cache, the connection information is right here. I have the password, the name of the server, and the user that I need to use. So I'll just go to my web application and install the NuGet package to handle memcache. In my case, it's NMcache, as you can see here. I'm using NMcache. And I'll add the relevant code to memcache, which I already did in this provider. This is using the memcache client configuration and let me scroll a bit up. And the memcache client object. And of course, the configuration to this is also from the web config. So let me just go ahead and open the web config. Now, this is the web config not of my local solution. This is the web config of my Azure website. As you can see, it says here remote. Okay, so if I change the configuration here, it will also change in the website, and I'll be able to refresh and see that I'm actually using memcache now instead of Couchbase. So as you can see, first of all, I have the memcache information here. This is the same information I showed you in the current portal. And the only thing I need to do is change the way my code uses the cache provider. So if you look at the controller, when I create the controller, I have the option here to select the cache provider. And according to the cache provider I have in my app settings, it will choose the current matching cache provider. Okay, so this is a bug. Let me just deploy that again. Deployment to website takes about 3 seconds, 2, 1, and done. So let's go back to the web config. Can ignore that. Let's go back to the web config and change my solution to use memcache. Let's just verify it's the same spelling. Yeah. Okay. So I'm changing this to memcache. It will use this configuration. And I just need to create this memcache solution from the store with a few clicks of the button, and I get a memcache solution. I just need to save that. Once I save it, my application will restart itself. I can then hit enter again, reload the application. And once I go to the to-do page, just let's wait for it to load. Okay, go to the to-do page. It will load the items for today, which is 1 item. I can also load the items for tomorrow, just so I'll have the cache populated with more than 1 item. Let's give it a second. Okay, so I have the item here. I can go on ahead and see tomorrow's items. Okay, now if I go back to my dashboard and refresh it, you'll be able to see that I have now 2 items. These are the 2 lists that I have for my caching. So the only thing I need to do is, first of all, create the memcache solution in the Azure store. The second thing I have to do is configure my client to use that memcache using NM or any other client that you have for memcache. So this is basically a way, for example, to migrate your applications from your on-prem using memcache to Azure. Just migrate your web application, create a memcache from the store, and just change the configuration to use that memcache solution. Okay. So this was another option of using caching solution, not by installing a virtual machine, but rather by just setting up something from the Azure store. Or on the same note, you can just get a third party from any other place that uses Azure, specifically preferably to use Azure because of the higher throughput that we will gain by using the same data center for our caching and for our web application hosting, of course. Okay. So the third option that I mentioned that was possible is using services that are built into Azure, caching services from Azure. And the caching service that I want to talk about today is the Redis Cache service that is available, of course, for on-prem, but also in Azure as a service. So first of all, what is the Redis Cache? Redis Cache is a caching solution that exists for several years, many years actually. It's supported both on Linux and on Windows. It was ported to Windows a couple of years ago, I think it was last year, by MS OpenTech. And of course, newer versions being developed all the time. In addition to storing items in Redis just by using keys and values, the values being strings or serialized entities that you serialize into a binary form, what we can also do is we can group items. And this is one of the benefits of using Redis, that you can have more than just a key value store. For example, I can group items into a list that I can access according to an index. I can group items into a hash. So I can actually have inside the key I can have some sort of a dictionary. Okay? This actually proved quite useful in my situation in this demo, because in this demo I'm using a list of to-do items per date. So when I add an item, I just want to add an item to the list of items of that specific date. Okay, when I remove an item, I go to that specific date in the cache, and I want to remove an item from that list. When I used memcache and when I used Couchbase, so let me just show you how it was done. So for example, when I used Couchbase to remove an item from the list, what I did is get the entire list from the cache. This is the one. This one retrieves a list of all the to-do items. I then searched the list for that to-do item, removed only that item from the list, and then stored the list back again in the cache, only with that item being missing. So I had to pull the entire list. In this demo, I only had one to-do item, but if I had 100 to-do items, I would have had to pull that entire list to my machine, remove the items. So for example, if I have 100 items, pull the 100 items, remove one, and place back those 99 items in the cache. When I use Redis, for example, I can use hash sets. And in hashes, I can actually store a dictionary for my current date. And in that dictionary, have each item using its own ID. So for example, if I'm using Redis to do that same operation, what I need to do is, first of all, just check if I have if I have a list, a hash for the date of the removed item. And if I have a list of those items, I can just go to hash delete, specify the key that is the date I'm trying to remove from, and the ID of that specific item which I'm removing. So I'm actually just sending one command to my cache service saying, in that date, to remove the item with the following ID. I don't need to pull the entire list to my machine and then put it back in the cache. I can just work on a set of items identified by that ID and just remove items and plant new items when I need. Okay, this is a lot easier to work with when you have special types of things that you want to store in the cache, such as recent updates, new stickers, that sort of things, where you just want to put new stuff in a list, remove things from the beginning of the list, place items at the end of the list. That's also possible. So there are a lot of different ways to represent items in Redis, and this is one of the strengths of this caching solution. Other than that, it's just super fast. Okay, you can call it a cache plus. Now, of course, just like any other caching solution, Redis also supports evictions, also supports sliding expirations, supports transactions. For example, I can do a transaction where I place item, update items, remove items in one transaction, which either succeeds or fails. It even has its own pub/sub mechanism. So for example, if you're using Signaler in Azure, you can have Redis as your backplane for the scale out of your web servers. Okay, and as I said, it's super fast, so Signaler will just work seamlessly on multiple servers. Redis also has a lot of client APIs, so whether you're using .NET on Azure or Java on Azure or PHP or Python or Node.js, all of those platforms, and of course other more, have client APIs to use Redis. Okay, it's very simple. I can even use Redis from command line. Now, as I mentioned before, Redis comes in multiple flavors. We have Redis for Linux, Redis for Windows, and of course Redis as a service in Azure. So the first thing I want to show you is how I can actually use Redis on Windows by using a virtual machine, just like the bring your own sample I showed before. So in addition to my Couchbase server, I also created another server on which I installed Redis. Okay, so I have my Redis VM and I have it on remote here. So I downloaded this Redis solution from GitHub. You can find Redis on GitHub for Redis for Windows. We'll see at the end of the session a resource slide where you can see the links to download everything. So I downloaded Redis. Of course, Redis itself comes as an executable, but of course I won't want to start an executable simply by double-clicking in a VM, because if it crashes, I need to remote log into the machine and then start it again. So instead, there is a document here showing how to install Redis as a Windows service, and that's what I did. Now, as you can see, I have Redis here as a Windows service set to automatically start if the machine restarts because of updates or stuff like that. So I don't need to worry about my cache being online. If you do want to try it out without the cache service, you can stop that cache Windows service, of course. I can stop the service and just go ahead and load the Redis server. Okay, so now I have a server ready to go. I can, of course, also open the Redis CLI tools, the client tools, and I can check, for example, give me all the keys in the cache. So as you can see, there are a couple of items already in the cache, probably from a previous load which persisted them. I can, of course, clean this up, flush. Okay, now my cache is empty. So I can use this Redis server executable. I can use it, for example, just as a service, which I prefer. So let me just close this and start this again. Let's connect to it again, because this is a different server. Okay. So I have Redis running on Windows. The IP of this machine is 2.20. And let's go back to my to-do application. By the way, I will have this application online for you to download after this session, so you can go ahead and download and check the client API for all of these caching solutions and how to configure them to work with Azure, which basically just specify the IP of that virtual machine. So I have this Redis cache provider which I used. To use Redis in either Azure or on-prem, you have multiple client APIs. For this one, I used Stack Exchange, which comes built in with the, let me just show it to you. Okay, I installed the Redis Session State Provider. This allows you to persist your state, your ASP.NET state object, to Redis instead of storing it in memory. So just like you have the state persisted to a database using the built-in class libraries, you can also install the Redis Session State Provider NuGet package and have that state stored in Redis, okay, which allows it to load a lot faster. And that solution uses the Stack Exchange Redis. There are two versions, the Stack Exchange Redis and the Stack Exchange Redis strong name. So I'm using the strong name, but the API is the same API. So as you can see here, to use Redis, I'm creating an iDatabase. Redis has multiple databases that you can use. That is the multi-tenant environment that I mentioned at the beginning of the session, the way that I can have one server that has Redis in it and just split my applications that use that server to different databases. Okay, so each database has an ID. The default one is ID 0. I have up to 16, 32, 64. I can define how many I want. And that's the way I have in Redis to split my applications, but still use the same server to store all the information. So I'm using an iDatabase to initialize it. I call the get cache client. So I'm loading my Redis connection string. We'll see it in a second. And then I'm using the connection multiplexer to connect to that Redis cache server. So in our case, my Redis connection string looks as follows. I'm using the address of my virtual machine, 2.20. Currently, I'm not using SSL because, well, I'm inside Azure, inside the VNet, so I don't have to use an SSL. But of course, if you want it to be secured from the ground to the top, you'll probably want to use SSL. I just didn't install a certificate yet, so I didn't want to bother myself with it. So I'm using this Redis connection string, and because my website and my Redis VM are in the same virtual network, it will just work seamlessly. So all I need to do is go here and change this value to Redis. Again, I'm using the remote one, so I can just save this. It will save it in my application, and I'll just need to refresh my application. So let's go back to the application for the 16. Press Enter. It will load the information from the table storage and then place it in Redis for the next time I hit the same page. So give it a second because I just loaded the cache. We can do that again. And the second time it should load faster. Okay, can do that again just in case. And probably it works slower because I'm running an ASP on the website. Probably have some code in it to go to the cache and then do other stuff. So let's go to the Redis here, open the CLI, and let's see what we have. So first of all, as you can see, I have an item here. I can check this item and get all the items that are stored for this key. And as you can see, for this key, I have an ID, 846, and the other stuff. And here, as you can see, I have a string that is actually a JSON string. So when you're using Redis, you need to store your items as strings. Of course, they can also be scalar values, such as an integer. But basically, you need to serialize your objects to some sort of a string. So you can use a memory serialization, such as a binary formatter or stuff like that. I chose to use JSON because it's more readable for this demo, at least. So you can just go ahead and check what I'm storing in the cache. So as you can see, this is a JSON describing the item. And if I had multiple items on the same date, let's try that out. Catch a flight back home. And let's create another one. Pick up my luggage for tomorrow. Hopefully, I'll pick up my luggage after I land. Okay, you can go to that date. And I should see those two items. I can go back to the VM, hit it again. The ID represents the date, as you can see, September 16th. And now I'm supposed to get the two items. Let's try to do it again. Something happened to the CLI. Come on. Is my cache service okay? Try to close. Windows don't get closed. Well, it should work. Something got stuck for some reason. It looks like a Windows issue because I can't close the command line. Let's try to do the following. We'll give it a couple of seconds and we'll get, oh, here it goes. Okay, keys. Okay, let's get this one. and give it a second. As you can see, we're getting the 2 items of that day, pick up my luggage and catch a flight back home, not necessarily in that order. So as you can see, installing Redis on a VM is not that hard. We can actually run it as a Windows service. But instead of doing that, what we will probably want to do, if we want to use Redis, is to use Redis as a cache service. So Azure Redis Cache is a cache service that you can just create in a couple of clicks. You can define the size of the cache that you want. You can define the type of tier that you want, whether it's a basic or a standard tier. We'll talk in a couple of seconds about the difference between these 2 types. You can even create, when you create a standard tier cache, you also get 2 server nodes. So one acts as a master, the other acts as a slave, and they have replication between them. This is, by the way, a basic option of Redis, to have a master-slave replication where each item is replicated to a slave. But the Redis solution that you get as a service actually has something in addition. If the master fails for some reason, the slave is automatically propagated to become the master. Okay, so you actually have also the option of having a high availability server with a high SLA of 99.99. At least that is the SLA that will be once Redis is out of preview. And in addition to that, because this is a public service that you can access from anywhere, basically, including your on-prem servers, this solution is secured. So you have a TLS connection, a secure TCP connection to that service, and you have an authentication using a password, okay, or a passkey. Currently, it's in preview, but I expect that soon it will be already published and be globally available. So as I explained, there is a basic tier and a standard tier. The major difference between the basic and the standard tier is when it comes to SLA and higher throughput. So first of all, to get a master slave node, you need to use the standard version. Okay, in the basic version, you only get 1 instance, which is the master instance. You don't get a slave, so you don't get replication and high availability. So your SLA is not guaranteed in the basic tiers. For selecting different sizes of cache, you have that option both in basic and in standard, starting from 250 megabytes, which might be okay for your dev environment and test environment. But for production, you might need more than that, so you can scale to 1 gigabyte, 5 gigabytes, up to currently 53 gigabytes of cache. Now, of course, the more cache you need, the more you will pay. If you need to start with something small, say 1 gigabyte of cache, you can do that and then scale up to larger sizes. You don't need to delete that cache service and create a new one. You can just go to the portal. I will show exactly how to do that and scale it up to a larger cache. When you use the smallest cache, the 250 megabyte cache, you should be aware that there is a capping on the throughput. So the throughput is limited. You won't be able to use it as fast as you use, for example, Redis that has a 1 gigabyte cache or more. But for development, for first unit tests and that sort of stuff, it will be okay. For staging and, of course, for production, use the 1 gigabyte and above caches. That's at least my recommendation. And, of course, you can see there's a price list here. This is currently for the preview. The prices will change when Redis goes GA. So you should probably just check the correct price once you want to use that. Okay. As for security, both the basic and the standard have the same features because it's a public service, so it must be secured. So let's first understand, when I'm using Redis Cache as a service, I can access it from anywhere. It can be a website, a cloud service, a virtual machine, or even my on-prem environment. If you don't want to install Redis VMs on your on-prem network, you can actually not install, but create a Redis cache service in Azure and use it. Of course, the throughput won't be that great because you're crossing the internet boundary here from your network to the Azure data center. But if you are near the data center and you can use the application with that delayed throughput, then that's okay. So let's go ahead and see how to create this service cache and how to use it. So I'll go to the new management portal. In the new management portal, you can create the Redis cache. By the way, that's the only portal that you can do it from. In the current portal, you don't have the Redis option, so you'll have to switch to the new portal. And I can just click New and scroll down here to Redis cache, which is currently in preview. And as you can see here, I can pick the name of my Redis cache. Okay, verify that it's not in use. Choose the pricing tier that I want. Let's see the entire list. So as you can see, I can get from 250 megabytes and up to 53 gigabytes, either as standard or basic. And you get a list of exactly the feature that you get in each tier. So for example, as you can see, in this solution, you get a replica. In basic, you don't get a replica. The 250, in comparison to the other, has a limited throughput. The other ones don't have it. Also, the 250 has a shared infrastructure, meaning you're actually not using a dedicated VM. It's actually a VM that is used by multiple cache clients. So that's why you also get the limited throughput. If you choose the larger cache sizes, 1 gigabyte and above, you get a dedicated instance. Okay, that instance, by the way, is an A1 machine. Redis cache is a single-threaded solution, but it allows a very high throughput, although it's single-threaded. So you don't actually need to have multiple CPUs to run Redis cache. Okay, you can manage with one CPU. Just have it fast. So I'll select the one that I need. For example, let's pick the 1 gigabyte. Okay. I can choose the subscription where I want to create it and the location. Redis cache is supported, or will be supported once it be globally available in all the regions. Currently, I haven't really checked, but I think that you should see all the regions here. When it was just announced back in TechEd earlier this year, we had only about 4 or 5 regions. But now, from looking at the list, I see that most of the regions are already covered. So I can just select the location and click Create. Now, once I click Create, underneath the hood, Azure will create special cloud services to host this Redis cache. So for example, if I'm picking the standard with the master-slave replication, I actually get two worker nodes, instances of a worker role, okay, inside the cloud service. You can't, of course, see that cloud service. But the reason I'm saying this is because if you ever tried cloud services, you know it takes about 5 to 7 minutes to create a cloud service. So that is about the same time it takes to create a Redis cache. So once I hit create, it will take a couple of minutes. That's why I won't do that currently. Instead, I'll show you the Redis cache that I already created in advance. And this is my cache. Okay, as you can see, this is the cache which I created in advance. And as you can see, I can get a list of properties. So for example, the address of this cache, the port for the unsecured and the secured ports. I can check information such as the key to that cache, the authentication key. And of course, get statistics about the usage of that cache. And change the pricing tier if I want to scale up from 1 gigabyte to more than that. Even create rules, alert rules, to send me an email once I use too much memory or once I have a lot of misses in the cache. So I can just go ahead and enter new rules. So for example, cache hits, cache misses, high CPU, used memory. And just, for example, send me an email once I'm getting to 90% exhaustion of my memory, okay, which can be quite useful in order to know when I need to scale up my cache. So once I have that information, all I need to do is go back to my application and change the connection string to my cache. So instead of using this setting, I will choose to use this setting, which I already created. As you can see, this has the Redis connection string pointing to my Redis cache. I'm using SSL this time because this is a public service, and I'm supplying the password for this solution. For this cache service. In addition, as I mentioned, I can also persist my state to Redis. So if I scroll down, you can see that I have the session state with a provider for Redis. Let me just sort this out. As you can see, these have the same settings as my Redis connection string. These settings are for the session state provider. So I have a timeout of 5 seconds for the request. This is the name. This is not the name, actually. I need to change that. And I also need to change the key. So let me just copy that. This is a previous demo. Okay, oh, wait a minute. One other setting. And, oh, yeah, it's still Redis. Save the changes. And now my application with the same code that I showed before, get the list of items. If I add an item, add it to the hash in Redis. But instead of using that VM that I used before, I'm just using the cache service. Okay, so I can go back to my application. Tasks viewed by the 16th. First time it goes to the cache doesn't have those entries. It will pull them from the table, populate the cache, and once I see those items showing up, I can go on ahead and, for example, open my Redis command line. Okay, so it's showing up. I can open my Redis command line and connect to that cache, so I can also do that for my machine, because it's not a VM. Get the keys. As you can see, this is the key for the 16th. Okay, and as you can see, here are the items which were placed in the cache. As I mentioned before, I'm also using the session state provider. So I can also go ahead and, for example, change my background. This background is stored in the session state. So I can change it from white to blue and then back to white. Just before we switch to blue, let me just fix one thing that I noticed. This should be custom because we need to use the custom session provider. Save it again. Now we can go back to our list. Just refresh the page to load the new web config. And now when I press blue to change the background to blue, that setting will be stored in my session state. So if I go back to my Redis CLI and hit keys again, you'll be able to see that I have this new key here, which is actually the session state key. So if I'll just copy it, and again, session state is also saved as a hash, because under that key, there's a key value of all your session state. hgetAll, place that. And you'll see I have this theme. This is the item I placed in the cache, and the value is blue. Okay, the rest is the type of the item and everything else that is stored in a state object. So if I switch to white, okay, go back again, you can see that now it says white. Okay, so I'm also able not to just use Redis as a cache store to hold my data that I put from the table. I can also use Redis to use it as a state provider for my sessions. So I guess one of the things that you want to know about all these different caching solutions is how well they perform. So first of all, they perform very well once they are in Azure and not connecting on-prem to the cloud. Preferably, they should all be in the same data center to perform the best. Of course, there are differences between the solutions. For example, Redis service is very well known for its high-speed get commands. Okay, for put and for delete, it's a bit less performing, but for get commands, which is mostly what we do in cache, it is very a very good service. And as you can see, this actually provides the best response time in comparison to other caching solutions, in comparison to Memcache and Couchbase. Of course, this is just a simple benchmark that I used in order to test how much time it will take to put 1,000 items and then to retrieve them and then to delete them. Okay, of course, the benchmark might change if you do concurrent testing of 10 or 100 users, or if you use large entities or smaller entities, it might change accordingly. This is just one type of benchmark. As you can see, Redis service is acting better than a Redis VM. Maybe if I used a machine with more memory or with more throughput, I'm using an A1 machine that doesn't have a lot of IOPS in comparison to, say, an A2 or an A3 machine. But basically, as you can see, Redis service is performing quite well. Memcache is also performing well as a service. I guess that this caching solution has a lot of benefits of using it. If you want to install your own VM, well, as you can see, Couchbase is also performing very well. Just to clarify, 2.2500 for 1,000 operations means that actually a GET request for an item from the cache takes about 2.5 milliseconds, which is very good. Okay. Now, if you want to deploy your own caching solution to Azure on a VM or find a caching service that is provided by a third party, just take into consideration a couple of things. First of all, when it comes to network and security, are you using the public IP or the private IP of that caching solution? Okay, it changes the way that you need to secure your connection, and whether, of course, you're using a port that is open to the public or you're using an internal port that is only accessible from within the VNet or from a VPN. When it comes to clustering, do you access only the main server or multiple servers? If it's multiple servers, you need to open maybe multiple ports if it's under the same load balanced endpoint, or maybe create separate VMs with separate IPs and endpoints. You need to figure out how to do it properly if you're using more than one machine for caching, and you need the clustering and not only replication of a master slave. When it comes to development, do you need a caching solution for development, and do you want it to be in the cloud and access the cloud for each fetch and each add item to the cache, or are you in the need to place that caching solution locally on-prem, for example, on your own machine maybe? So, for example, we saw that Redis has a VM option, so we can just grab that solution from GitHub, run it on our own machine, and then use Redis locally, and when we are ready to deploy the application, use Redis in the cloud. Okay, I can't say that, for example, for other caching solutions that might only be available in the cloud. How do you handle VM restarts? Eventually, a VM will restart itself, for example, when Azure performs update to the host environment and stuff like that. Do you need to persist your data? If so, then you need to select a caching solution that has the ability to persist data. Okay, and lastly, of course, the price. As we saw, for example, for Azure Redis Cache, there are different prices for different levels and different features of the cache. So choose wisely, and of course, you saw for Redis, you can upgrade the size of the cache as you go along, and you discover that you need more memory. Okay, so just create a checklist and verify that you answer every one of these when you select your caching solution. Now, as regards to resources, you have a bunch of resources here, how to use Memcache and how to deploy it to Azure if you want to deploy it on a VM, for example. Couchbase, and there's a great link of how to install Couchbase on a virtual machine in Azure and how to create multiple nodes. For the Azure Redis Cache, first of all, there's some information here how to deploy Redis on a VM, and of course, how to use the Redis cache service. And if you want to deploy the original Redis solution for Linux, there's also a link here to deploy Redis on Linux. That being said, there's also a link here for the code example that you just seen. I will also post the code example that I used to do that benchmark. So if you want to see how to use the different caching solutions and test for the benchmark, that would also be available for download. So thank you very much for coming to Azure Conf. Enjoy the rest of the conference and have a good day. Goodbye.